Weston differential pulley consists of lower and upper block. The upper block has cocked grooves, one of which has the radius of 125 mm and the other has a radius of 115 mm. If the efficiency is equal to 40%, then effort required to raise the load of 1500 Newton is dash. So in the Weston pulley, you find the larger diameter as capital D, which is 2 times of radius, that is 2 into 125, which is 250. And the smaller diameter onto which the load has been connected, that is small d, equal to 2 times of 115, which is 230 mm. Next is the mechanical advantage needs to be calculated, or sorry, the effort has to be calculated. Efficiency of the drive is 40%. Okay, so first we begin with computing velocity ratio. Velocity ratio is equal to, that's VR, 2 times of capital D divided by capital D minus small d, which is 250 into 2 divided by 250 minus 230, and this is equal to 25. And next is mechanical advantage. Mechanical advantage, which is generalizedly expressed as load by effort, and that's equal to W by P, which is W is not known, and W is 1500 and P is not known, but efficiency has been mentioned. So efficiency is expressed as mechanical advantage divided by velocity ratio. So this is equal to 40%, that's 0.4. 1500 by P whole divided by velocity ratio is 25. So here 25 into 0.4 is 10. 10 by, or 1500 by 10 is 150 newtons is the effort.